Hello and welcome. In this video we are going to look at how we can change the rate of a chemical reaction and what factors are involved, and by the end of it you should be able to explain how the factors change rates of chemical reactions. Now the first one that we need to look at is temperature, and temperature has an effect, but you should be able to explain what's happening in terms of particles and how they cause a change. The second one we're looking at is concentration. Third one is pressure, and pressure is usually to do with gases, or in fact it's always involving gases. And the last one is surface area. Now there's four I've mentioned here. There actually is another one which is catalysts, but I'm dealing with that in a separate video. So for now let's crack on with this. Now previously we looked at different ways of looking at the products and the way the reactions change. So here we had a mass loss and we were measuring that. Here we were looking at the amount of gas produced, and here we had two solutions. One was sodium thiosulfate and the other one was hydrochloric acid, and we were looking at how these could be measured. But next step we need to really talk about is how the particles are behaving. So whether you've got the marble chip particles, for example in this experiment here, reacting with acid particles, or whether you've got two solutions and their particles reacting, you have to be aware that for a reaction to happen the particles have to collide. Furthermore, the particles have to collide, but they have to collide with enough energy. So if this particle here collided with this one here, if it didn't collide with enough energy, you wouldn't get a reaction. It has to collide with enough energy to cause a reaction to happen, and that minimum energy, let's do that tidily, that minimum energy required is called the activation energy. So that's the minimum energy required for a reaction to happen between two colliding particles. Now let's have a look at how that affects our four different factors. We can say that anything that changes the frequency of collisions will change the rate of a reaction. So here we're looking at the first one, which is concentration, and we're going to look at how that can have an effect on the rate of reaction. So I've got four flasks here. Each one has a different concentration of solution inside there, or maybe a pair of solutions, but one of those in each one has a higher concentration as we go up. Now we could look at the reaction, measure it in some way, either with gas given off or mass loss or wherever it is we want to measure, and we could plot the results like this. So we've got concentration along the bottom, forgot to add the units, and we've got rate of reaction along the side. I haven't added units there because it could be a whole variety of different things, but we could measure the reaction for each of these concentrations and see how it changed. And as you can see from the graph, the rate of reaction is increasing, and we could happily draw a line of best fit through the points. Not all the points often land in a straight line because there might be inaccuracies in measurements or something like that, but we generally get a straight line that shows that as you increase the concentration you increase the rate of reaction. Now you should be able to explain how that happens. So let's have a look at what's going on in this one, in this one, and in this one. So if we expand what was going on and look at the particles, you can see for the first one where we have, in fact let's move it over here, where we have a low concentration of the two particles, we can see that there's only a few in a certain volume. In the second one we have more, and in the third one we have more still. So as you can imagine, this might increase the rate of collisions between the particles, and if you're explaining how increasing concentration increases the rate of reaction, you should bear this sort of diagram in mind. Remember, it's the same amount of volume, it's a higher number of particles in a given amount of volume. And how do we explain it? Well, increasing concentration increases the frequency of the collisions, and you could actually say, if you wanted to, frequency of successful collisions. By successful collisions we mean ones that have the activation energy. Okay, so the next line after that is then we have increase in the frequency of collisions, and that increases the rate of reaction. Now remember, increasing concentration means increasing the number of particles in a given volume of solution. So as you increase those, particles become more packed in, more close together, so you increase the frequency or the chance of a successful collision happening. The next one we're looking at is temperature. So again, you can imagine we've got two solutions reacting together. We've got 4